Okay, for the second part of 5.1, let's go over some factoring methods before we look at some more complex trig functions to simplify. So whenever we're asked to factor or whenever factoring is the best option, we have to remember we can take out the greatest common factor, right? That means just kind of look at each term or all terms and see what factor they have in common. If there's a common factor like x squared, like here, in both terms, we write that factor first, and then it's as if we're dividing that factor out, and we say, okay, when we divide that factor out, what do we have left? We have a y here, minus, here, x squared divided by x squared cancels out to 1, so minus 1. So when we factor, we don't want to lose any of the factors. The greatest common factor, the GCF, goes in front, and then whatever's left over stays in the parentheses. We can also use the X method or the box method to factor something like a squared trig function. So x squared minus 2x plus 1 is what we would have seen in like algebra 1. We might see something like sine squared minus 2 sine plus 1. Right? So we just remember factoring with X method, we're looking for two numbers that multiply to 1. It's like our AC method. And they have to add up to b, which is negative 2. Right? In this case, it'll be it'll be negative 1 and negative 1. So then we could say this term factors to x minus 1, x minus 1. Okay, and so of course we have factor by grouping we can use. We also have difference of squareds. Or difference of cubes. These are kind of formulaic ways to factor. We can use all of those to help us simplify expressions. So this example specifically tells us to factor, then simplify the expression. So if I look at my two terms, sine squared times cosecant squared, that's my first term, and then minus sine squared. I look at those two terms and I start with GCF. Is there a greatest common factor between the two terms? Yeah. There's a factor of sine squared and a factor of sine squared. So that's going to be my GCF. And then I say, well, when I divide out sine squared, what am I left over with? I'm left with cosecant squared minus, here when I divide out sine squared, it cancels to just 1. And then I've factored. After I factor, so this is my factored form, it asks me to simplify. So now I go back to my trig identities and I say, well, what do I know about sine squared or about cosecant squared minus 1? And remember the problem before, sine squared is one of my Pythagorean triples, but I don't want to make it a bigger problem, so I'm going to leave sine squared alone. But cosecant squared minus 1 is one that when we look here, there is a way I can take cosecant squared, rearrange this Pythagorean identity so that it matches what I have. And just like we did with the previous, if I remove or subtract 1 from both sides, I can rewrite this as cotan squared theta equals cosecant squared theta minus 1. So that's a variation of this Pythagorean identity. So I'm going to use that. The fact that cosecant squared minus 1 is equivalent to cotan squared. And then the sine squared, we didn't do anything with it, so I'm going to leave it as sine squared. I've simplified a little bit. There were two terms here, right? It was a binomial, now it's just a monomial. But I can also say, well, cotan is cosine over sine. So let me rewrite this as cosine over sine and see if I can simplify anything more. Running out of space. And again, remember, cotan is cosine over sine, but because it's squared, both the numerator and denominator both need to be squared. And then because I didn't change the sine squared, I'm just rewriting that here. So I have sine squared times cos squared over sine squared. My sine squared cancels out with the sine squared on the denominator, and I'm left with just cosine squared. Okay, so I've simplified this expression all the way down to just cosine squared. All right, let's try the next one. Next one says cosine squared x minus 4. Remember our direction said to factor, then simplify. So let's factor cosine squared minus 4. So when I look at cosine squared x minus 4, I have a squared term minus another squared term. So I can think of that as cosine squared x minus 2 squared. So technically this is the difference of two squareds. I'm just going to put little equals. All right, didn't do anything with the denominator. I'm just going to rewrite it. When I have the difference of two squares, remember x squared minus y squared, it's just x plus y, x minus y. So I'm going to factor the numerator into cos x minus 2 times cos x plus 2. Right? And all I really did was see that, oh, I have two squared terms and I'm subtracting them. So the difference of two squares, and this is our formula. Okay, if you want to kind of go back to our algebra 1, a squared minus b squared, when we're factoring, is equivalent to a minus b times a plus b. Of course, ours looks a little more complicated because we have trig functions now, but it's the same concept. Denominator, again, I did nothing with. And really, this problem was all algebra 1. I didn't do any changing to a different trig function, using any identities. All I did was factor the numerator, right? Difference of two squareds. And now I can, again, use my algebra and say, well, cosine minus 2 cancels out with cosine minus 2, and all I'm left over with is the factor of cosine x plus 2. So it simplifies all the way down to cosine x plus 2. All right, let's try one more. And again, our directions were factor and then simplify. So I have cos squared minus 2 cos plus 1. Now the problem we did above, I technically could have used u substitution, right? But I didn't have to. So you can use u substitution, which I'm going to show you now, if you need to. It's always an option. And what u substitution is I'm just going to let the variable u, which is nice and easy, it's one little letter, represent something in my equation. What I notice is that I have cos squared and I have a cosine. So that's kind of like when I would have a x squared and an x in an equation, right? It's a quadratic. So I'm going to let u, just a random variable that I chose, we call it u substitution because we're letting u substitute in for something larger and more complicated. I'm going to let it equal cosine x. So when I come over here and rewrite the problem, I'm going to rewrite it as u squared, right? If u is cosine, then u squared is cosine squared, minus 2 times u, wherever I see cosine, I'm replacing it with a u, and then plus 1. Now when I look at this is a little bit easier to see that, oh, this is a quadratic. I can use the x method or the box method to factor, and then when I come back to my final answer, I have to go back and say, okay, I substituted u for cosine x, I substituted u in there, so I have to go back and push it back. So let's just factor for now. I have u squared minus 2u plus 1. X method says I'm looking for two numbers that multiply to 1, add to negative 2, right, which would be negative 1 and negative 1. So this guy factors to u minus 1 times u minus 1. Right? And again, with u substitution, we use it just to make our problem look a little easier, and then we go back and plug in. U was cosine x, so let's go back and replace u with a cosine x minus 1, and again here, cosine x minus 1. Okay, so our problem says factor and then simplify. So really, This term here, cosine x minus 1, cosine x minus 1, it's the exact same term, so I could rewrite this as cosine x minus 1 squared. Okay, and then I look, I see a squared, but it's not cosine squared by itself. It's a squared term with some other pieces also. So I can't necessarily say what Pythagorean identity would match, but I could look and say, well, I've got something close to it. I have, oops, move this over. I have 1 minus cosine squared as the identity. If my expression is not exactly this and not exactly matching, I can't use it. So if I look here, I have cosine minus 1. It's not a cosine squared. It's not the right form. So I have to leave it like this. So this is my simplified form. Okay, so cosine minus 1 squared. Okay, so we will meet on Wednesday so you guys can ask questions if you have, but go ahead and try some of these trig expressions and try to simplify, try to factor, and see if you have questions.